Air handling units, AHUs, are essential components of heating, ventilation, and air conditioning, VAC, systems. They play a crucial role in controlling and distributing conditioned air within buildings. Here are 50 key points about air handling units. Air handling units, AHUs, are devices that circulate and condition air in VAC systems. AHUs are commonly used in commercial, industrial, and residential buildings. They help maintain indoor air quality by filtering and controlling the temperature and humidity of the air. AHUs consist of several components, including a fan, heating or cooling coil, filters, dampers, and a control system. The fan in an AHU is responsible for moving air through the system. Heating coils in AHUs warm up the air, while cooling coils cool it down. Filters in AHUs remove particles and pollutants from the incoming air. Dampers regulate the flow of air within the unit. Control systems manage and coordinate the operation of all these components. AHUs are typically located in mechanical rooms or on rooftops. They can be customized to suit specific VAC system requirements. AHUs can be used for both supply and return air in VAC systems. The primary function of an AHU is to condition outdoor air before distributing it throughout a building. They are designed to maintain comfort conditions, including temperature and humidity. Energy-efficient AHUs can help reduce operating costs. AHUs may be used in conjunction with energy recovery systems to capture and reuse heat or coolness from exhaust air. They come in various sizes, from small residential units to large commercial and industrial systems. AHUs may have multiple fans for redundancy and improved reliability. Some AHUs include built-in air purification and UVC germicidal lamp systems. AHUs can be part of centralized or decentralized VAC systems. Proper maintenance is essential to ensure the efficiency and longevity of AHUs. Regular filter replacement is necessary to maintain indoor air quality. AHUs may have variable air volume, VOV, systems to optimize energy usage. In healthcare settings, AHUs play a crucial role in maintaining sterile environments. They are designed to be robust and durable to withstand various environmental conditions. Noise levels from AHUs can be reduced using acoustic insulation. AHUs are used in clean rooms to control particulate levels and environmental conditions. Some AHUs have digital controls that allow for remote monitoring and adjustments. Heat recovery wheels can be incorporated into AHUs to recover thermal energy from exhaust air. In colder climates, AHUs may include frost protection measures to prevent freezing of coils. AHUs can be part of demand-controlled ventilation systems to optimize air exchange rates. They are often integrated with fire protection systems to prevent the spread of smoke and contaminants during a fire. AHUs may have variable frequency drives, VFDs, to adjust fan speed for energy savings. The selection of AHUs depends on factors such as building size, occupancy, and local climate. Energy-efficient AHUs may be eligible for energy efficiency incentives and rebates. AHUs can be configured for constant air volume, CAV, or variable air volume, VOV, operation. Some AHUs use enthalpy wheels to recover both heat and moisture from exhaust air. AHUs are essential in data centers to maintain optimal temperature and humidity levels. In marine applications, AHUs are used for ventilation and climate control. AHUs can be equipped with airside economizers to take advantage of free cooling. They may be part of hybrid VAC systems that combine multiple technologies. AHUs can be retrofitted or upgraded to improve energy efficiency. Some AHUs are designed for hazardous environments and are explosion-proof. They are subject to industry standards and regulations for safety and performance. Properly designed AHUs contribute to occupant comfort and productivity. AHUs can be configured to provide 100% outside air for specific applications. Advanced control algorithms can optimize AHU operation based on occupancy and weather conditions. In laboratories, AHUs are used to control airflows and maintain stable environments. Maintenance schedules for AHUs typically include inspections, cleaning, and calibration. AHUs are essential components of building systems that impact energy usage, indoor air quality, and overall occupant satisfaction. These 50 key points provide an overview of the important aspects of air handling units in HVAC systems.